Good evening. Tonight we're going to start with Lesson 14, Module 3. I can solve division word problems with remainders. Now we've been working on multiplication and we've been doing many word problems using multiplication. And a usual basic multiplication word problem would be Megan has 5 bags of cookies. There are 3 cookies in each bag. How many cookies does Megan have all together? Now that's a multiplication problem, and we would do 5 times 3 equals 15 cookies. Now, in division, there are 2 different ways that you can look at division. And this is called measurement division and partitive division. And measurement is basically how many groups can you make, whereas partitive division is you're looking how much is in each group. You're taking them apart. So let's get started tonight. Now at measurement division, we have this word problem. Megan has 15 cookies. She puts 3 cookies in each bag. How many bags can she fill? So that's basically looking how many groups do we have. So if we put 3 in each group until we get to 15, we will be able to find how many groups. So we have 1, 2, 3, 1, 2, 3, that makes 6, 1, 2, 3, that makes 9, 1, 2, 3, that makes 12, 1, 2, 3, that makes 15. So now we group them together. 1, 2, 3, 4, 5. So in the measurement division word problem that we have here, we just made 5 groups. So she can have filled 5 bags, and that is an example of a measurement division word problem. Now in partitive division, this is an example of a partitive word problem. Megan has 5 bags of cookies. Altogether, she has 15 cookies. So they're giving us that total. They're not looking for a total, they're giving us a total. And there's that showing us that we're going to be dividing. There are the same number of cookies in each bag. How many cookies are in each bag? So you're hearing those keywords, each, same number. They give us a total. These are all telling us that we're going to be dividing. And when we're hearing the question, how many are in each bag, there is asking you how much is going into each section. So we're like breaking up that 15 and finding out how much can go in each bag. And then we're again, that's showing parts, partitive. So let's take 15 cookies. We have 5 bags, so let's make our 5 bags. 1, 2, 3, 4, 5. And we're going to split up 15 cookies. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that so far is 10. 1, 2, 3, 4, 5. Now we have 15 cookies. So how many cookies are in each bag? We've got 3 cookies in each bag. All right, so now you can see the difference between partitive division and measurement division. In measurement division, we're looking about the total of how many bags that she can fill, the big groups that you can get. Whereas partitive division, we're trying to find what's in each group. All right, so that's the difference between partitive division and measurement division. So when we're examining these word problems and seeing if we are going to divide, I'd like you to think about if you're looking at a partitive division or a measurement division word problem. And that might help you set up your drawing when we do the read, draw, write process. There are 12 students in PE class separated into 4 teams. How many students are in each team? Well, let's start reading that again. So we've got a total. There's our total, 12 students. And they're separated. There here's a little word that might help us knowing that we're going to be dividing into 4 teams. How many students are on each team? So we're looking at that partitive division because we want to know that we've got our groups. We got 4 groups. We want to know how many students will be in each of those groups. So this is partitive division. So let's make our 4 groups. We're going to draw this. 1, 2, 3, 4. And we got to have 12 students spread apart these teams, these 4 groups. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we look at our drawing here, we see that we have 3 students on each team. And this is an example of partitive division. If they gave us we have 3 students on each team, how many groups can we make? Then that would be a measurement division. How this would look as a division problem would be 12 divided by 4, or you could do 12 divided by 4 this way. These are 2 acceptable ways of dividing. All right, in our next problem, we've got 1 more student join the class described in the first problem. There are now 13 students to be divided into 4 teams. So we're looking now about how many students are going to be on each of these teams now that we have 13 students. And this is, again, a partitive division because we want to find out about how many students are going to be in each group. Because now there are 4 teams and there's 13 students. So this is going to look like this: 13 divided by 4, or 13 divided by 4. So how's this going to look like if we did the draw part of the read, draw, and write? We would have 4 teams, and we've got 13 students that we have to spread apart all these groups. So the 4 groups, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 can't fit into a group. So he is considered our remainder. So we've got 3 remainder 1. So that basically saying that we've got 3 students on each team with 1 student left over. So he doesn't have a team. So this would be an unequal team that got, he would have to be on another team, or placed in one team would have to have 4. But it had to be separated into equal groups. So this is an example, again, of a partitive division. All right, Christy bought 13 roses. If she puts 6 roses in each vase, how many vases will she use? Will there be any roses left over? All right, so this is an example of a measurement division word problem, because now they're asking for how many vases, which really means how many groups. Because we have the individual, she's going to put 6 roses in each vase, so we know how many are going into the vase. We just don't know how many groups we're going to make, how many vases we're going to have. And we know we have a total of 13 roses. So there we know we're going to be doing division. And I see over here left over, and there's going to be a remainder. So let's get our groups ready. All right, so let's take those 13 roses and spread them apart. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We've got 13 roses, but 6 roses are put into each vase. So let's find 6 roses. 1, 2, 3, 4, 5, 6. There's a group. 1, 2, 3, 4, 5, 6. And there's a group. So we have 2 groups, which means we've got 2 vases and 1 rose. Excuse me. Fix that. 1 rose left over, which looks something like this as the division problem. 13 divided by 6, or 16 into 13. 13 divided by 6. So these are the 2 ways of we can show how we can divide. But this is your drawing. This is how you're going to make an array to figure this out. But again, this is measurement division, because we're needed to understand how many groups. When we're looking for the groups, we're using measurement division. When we're finding how much are in each group, that's partitive division. Now, boys and girls, I just want to clarify. When we look at a division problem that looks like this, a lot of times children read the 6 divided by 13. That is incorrect. You kind of have to read it backwards. So 13 divided by 6. That is the correct way of saying that. Just be aware and be careful of that. All right, our last problem for this evening is on the library. It has 27 chairs and 5 tables. If the same number of chairs is placed in each table, the same number placed at each table, how many chairs can be placed at each table? Will there be any extra chairs? If so, this is looking for the remainder. We have a total of 27 chairs, and they're looking for, what do you think, measurement division or partitive division, if they're looking at how many chairs are at each table? Well, they're looking to solve a partitive division, because we have to find out how much are in each of those groups. So let's start setting this up. Let's start making our 5 tables. 1, 2, 3, 4, and 5. So we have 5 tables. And how many are going to go in each group? We have 27. So let's start spreading apart those 27 chairs. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 20, there it is, 27. All right, but notice, I was gonna keep on going. Notice that we've got 2 extra chairs here. That is not going to fit, because they have to have the same number of chairs. So we have got 5 chairs at each table, and there's going to be 2 extra chairs. And how does that look like? Well, it looks like this. 27 divided by 5 equals 5 remainder 2. Now, boys and girls, this is an example of a partitive division, because we're looking for how much is in each group. We're breaking them apart to find out how much is in each group. Measurement division is we're looking at how many groups. All right? All right. It's better to try and fail than fail to try. All right, so let's give it your best shot. To help you with this next one, use the RDW process to help solve. There are 19 identical socks. How many pairs of socks are there? Will there be any socks without a match? If so, how many? Remember, you're probably looking, where's the other number that I could use to divide by? Well, guys, remember what a pair is. A pair means 2. Our next problem is about Roxanne. She has 25 pencils. She packs 6 pencils into each box. How many boxes does she have? And how many pencils are left over? Now, try to use an array to help you draw it out to see how many boxes she has and how many are left over. And think about what type of division is this? Is this a measurement division problem or a partitive division problem? And your last word problem for tonight. Jean has 4 tomato plants. There are the same number of tomatoes on each plant. Altogether, there are 20 tomatoes. How many tomatoes are there on each tomato plant? And here's a famous quote from our basketball star, Michael Jordan. Don't be afraid to fail. Be afraid not to try. Okay, guys, have a great night, and we'll practice more of this tomorrow.